This video deals with graphs of polynomials as well as writing equations. Let's look at these four quartic graphs. I know that they're all even because the end behavior is up, up for all of them. Okay. Which of them have degree 4? Well, this one definitely has degree 4. They're fancier than parabolas. Okay, so the answer is all of them. They all have degree 4. How many zeros does a degree 4 polynomial have? How many zeros? Well, this graph right here has 4 x-intercepts. This one right here just has that 1. This one doesn't have any. This one has this 2. So how many zeros does a degree 4 polynomial have? Well, it has at most 4. But it could have less. In fact, it could have none. How many turning points does it have? A degree 4 has 1, 2, 3 turning points. At most. That's the curviest it could get. So at most 3. Okay, that was a nice little example of 4 different quartics, but let's sum it up in our notes here. For this polynomial right here, a sub n x to the n, so the nth power, how many turning points does the nth power have? N minus 1. And how many zeros could it have? It could have at most n zeros. Can't have more than that. If that was x to the 5th, I could factor it into 5 sets of parentheses. I can't get more than 5 x-intercepts out of that. All right, let's analyze this graph. So first of all, the end behavior. I'm looking at this negative x to the 5th, and I'm thinking that it goes like this, but that's not the answer you write on the answer line. We're going to say y equals negative 2, and then the highest degree is x to the 5th. So that's how the ends go, like a negative 2x to the 5th. All right, to find the zeros in the multiplicity, we're going to have to get this thing factored. So let's go ahead and write f of x equals, well, I'll take out negative, factor out a 2, and I'll take out an x, leaving us with x to the 4th minus 8x squared plus 16. All right, let's keep going, more factoring. We've got negative 2x out in front. And since this is x to the 4th, I'm going to factor it into x squared. This looks like a perfect square trinomial. This looks like a 4 and a 4. And if they're both negative, that would make a negative 8 in the middle. Now, this is certainly not done yet. F of x equals negative 2x, x plus 2x minus 2, x plus 2, x minus 2. 1, 2, 3, 4, 5 x's. Find the zeros, and of course, we always have to state the multiplicity. This one right here is an x. If I go ahead and write negative 2x equals 0 and divide both sides, I'll get 0. If it was just a number, there'd be no x, but that is a 0. So 0, 0 is an x-intercept, but the multiplicity is 1. All right, the next one is negative 2, 0. Negative 2, 0, but I notice that that factor appears twice. So the multiplicity is 2 times. And the last one's also a double, 2, 0 with multiplicity 2. Now let's go ahead and put some meanings to those multiplicities. If the multiplicity is odd, then it's going to cross. If the multiplicity is even, both of these are going to brush. The y-intercept, you would put 0 in for x. 0 in for x. 0 plus 0 plus 0 makes us 0. Draw the graph. Okay, I sure will. The x-intercepts are 0, 0, negative 2, 0, and positive 2, 0. The y-intercept is the same. The end behavior says it has to go up, and it has to go down. Okay, so let's put our pencil up here on this arrow, and let's approach negative 2. I'm approaching negative 2, and it says I need to brush it. So brush off that x-intercept. I'm approaching 0, and it says to cross. I got to cross through the x-axis. All right, this is looking kind of weird here because my end behavior is down. I'm approaching 2, but that has multiplicity 2, so I will brush. Oh, that's looking good. Okay, I just want to make sure that this graph is smooth and continuous, nice and curvy, no sharp bends. The domain, smooth and continuous, doesn't stop, all reals. The range, down to negative infinity, positive infinity, all reals. Is the range always all reals? The range for all these polynomial graphs? No. Take a look at this one right here. What's the range? It's not all reals. The range would be from 0, brackets, up to infinity. Okay, we're going to do a couple of writing equations by looking at the graph. Okay, and there's a couple of things that I want to make sure you always write down when you look at the graph. Okay, so here's the first couple basic questions. The first thing you should ask yourself, is this graph even or odd? Since it's going up, we're going to say it's even. The next thing I always want you to ask yourself and write down, what is the degree? The degree of this polynomial right here, since it has 4 x-intercepts, okay, it's definitely an even number. I'm not going to say 2, it's fancier than a parabola. I'm going to say the degree is 4, even with a degree of 4. Okay, you should also analyze this graph, and we need to make sure that we list all of the x-intercepts and the y-intercept for the graph that you see. So on the x-axis, I see -1, 0, -2, 0. I also see +1, 0, and +2, 0. The y-intercept is 1, 2, 3, 0, 4. Okay, so these are always the things you need to find: the degree, and if it's even or odd. And sometimes right here people catch a mistake. They say even, but then they write 3. Wait a minute, it's not 3 if it's even. All your x-intercepts and your y-intercept. All right, let's write the equation of the polynomial. So f of x equals. The first thing you need to write down is the letter a. Okay, that's very important because a lot of times people forget to find the a. If the degree is 4, we're going to write 4 sets of parentheses. And here's your x-intercept. So we've got x plus 1, x plus 2, x minus 1, x minus 2. Okay, and here comes the red marker again to write a note. Okay, use the y-intercept to calculate a. Please write this down. I'm going to look in your notes tomorrow and make sure that you wrote that very important hint down. That's the one thing people will forget to find, even though they know how to do this problem perfectly. So the y-intercept is 0, 4. The x is 0 and the y is 4. So in place of f of x, let's put 4. I'm trying to calculate a, and x is a 0. 0 plus 1 is 1. 0 plus 2 is 2. That's -1, that's -2. So all the x's turn into 0. 4 equals a. Negative times negative is going to cancel out. 2 times 2, that's a 4. All right, 4, that's nicer. Divide both sides by 4, and a is a 1. Okay. Now, a is not always equal to a 1. It just happens to be the answer in this case. So let's go ahead and put that value in for a. F of x equals 1. X plus 1, x plus 2, x minus 1, x minus 2. Now, it did say find the equation of the polynomial. Polynomial, meaning many terms. Many terms, not many factors. This is factored form. This is not polynomial form. So guess what we have to do? Multiply them together. And to do this nicely, why don't we find factors that multiply easily? For example, x plus 1, x minus 1 is a difference of squares. X squared minus 1. Let's take a look at x plus 2 and x minus 2. X squared minus 4. We're getting there. Since a is a 1, we don't really need to write that anymore. So the final answer is going to be x to the 4th, outers and inners, minus 5x squared plus 4. This is the equation of the polynomial graph that we saw in the beginning. Okay, let's do another one. Okay, so what are those questions you need to ask yourself? Look at this graph. Look very carefully at where it's touching, and look at the ends. Okay, so let's go ahead and state. Let me ask you: is it even or odd? Definitely even. Okay, so what's the degree? And some people say 3. 1, 2, 3. It's not 3. We just said it was even. If you look at the curves, there's 3 turning points. This has to be a degree 4. Has to be a degree 4. Okay, so let's list the x-intercepts and the y-intercepts. The x-intercepts are negative 2, 0, 1, 0, and 3, 0. Well, that's not going to cut it. I need degree 4. There's one more. Do you see it? I think we forgot to say it. There's one more right there on the x-axis. On the x-axis, you know where it is? Right there. Right there. What? If it brushes, that means it has to have even multiplicity. It can't appear as an x-intercept once. It has to appear twice. 1, 0. And let's just put a little note right there. Brush means even multiplicity. Okay, even multiplicity. You have to make sure that if things are brushing, you write them down twice. The y-intercept is 0, 3. And we will need that. Do you remember why? To help us find something. Okay, so let's go ahead and get this f of x started. We always start with an a. We'll have to find that. Degree is 4, so we're going to write 4 sets of parentheses. X plus 2, x minus 1, x minus 3, x minus 1. Okay, how do you find an a? Well, you use the y-intercept. Okay, so let's use 0 for x, 3 for y. Give me a y. 3, give me an a. I don't know it. 0 for x makes a 2, negative 1, negative 3, negative 1. Negative times negative cancels. So 3 equals, let's see, 2 times 3 is 6, so that's negative 6a. Okay, do your work carefully here because sometimes people mess up with the fractions. Divide both sides by negative 6. So a is negative 1/2. Oh, that's going to get messy. But we'll save that for the very end. That'll be the last thing that we do. Okay, so the polynomial is f of x equals negative 1/2. And then we write down all of the factors. And then we have to start multiplying. I don't see any conjugates, so it doesn't really matter how we do this. We just have to multiply 2 of them together. So let's go ahead and, I guess, do these 2 since they're next to each other. And then maybe I'll do these 2 since they're next to each other. It doesn't matter as long as the answer at the end is correct. It doesn't matter how you do this. So the first 2, x squared, outers and inners plus x, lasts minus 2. Here, the first x squared, outers and inners minus 4x, plus 3. Okay, now here comes the fun. We're going to save the negative 1/2 at the very end. Maybe what I'll do is start some big brackets. Big brackets, how big do they have to be? No, I won't close them yet. I have to distribute x squared, I'm going to color code this here, to all 3 terms. After I do that, I need to distribute a positive x to all 3 terms. After you do that, you need to distribute negative 2 to all three terms. So that's 3, 6, that's 9 terms. Okay, here we go. Give everybody x squared. That's going to make x to the 4th. Give him x squared, that's minus 4x cubed. Give him x squared, that's plus 3x squared. Okay, purple pen, you're done. Okay, orange pen, you're up. Everybody needs to get an x. That's going to be plus x cubed minus 4x squared plus 3x. Great job, orange, you're done. Pink pen, everybody needs to get negative 2. Negative 2x squared plus 8x minus 6. Close up the bracket. Okay, let's add all our like terms. We'll take care of the 1/2 at the very end. Okay, I guess I could just switch to parentheses now. The highest degree is 4. I only see x to the 4th. Cubics, where are you? Here's 1, here's 1. That's it. Minus 3x cubed. Squareds, you're up. 3x squared minus 4x squared minus 2x squared. That's negative 3x squared. Single x's, where are you? Plus 3x plus 8x, that's plus 11x minus 6. Okay, now distribute the negative 1/2. Final answer is negative 1/2 x to the 4th. Negative times negative is positive. 3 over 2. 3 over 2x cubed. Positive, again, 3 over 2x squared. So if you have a number, you times it by the 1, and you put it over 2. That's going to be negative 11 halves x, and that's going to be plus 3. I can determine how many zeros and turning points a polynomial will have at most. Yes, I could do that. And I can write the equation from our graph by multiplying everything out and finding the a value. Good job.